So we've been talking about functions in 2.1 and 2.2 and kind of talking in general about some of the aspects of different functions. But in 2.3, we're going to talk specifically about linear functions. Okay, and so we have a diagram here, or a graph, a chart, that is comparing the percentage of adult females who are literate. So this is like for a nation, probably, or a country. And there's a certain percentage of females that are literate, meaning they can read and write. So maybe there's only 10% of the female population that can read and write. But as it increases, getting close to 100%, where all adult females can read and write, it seems to have a relationship to the mortality of children under 5. So how many children are not making it past the age of 5? So if there is 0 adult literacy, female adult literacy, then it looks like it's about 200 and maybe 60 deaths per 1,000 for children under the age of 5. And then you can see as the literacy increases, the amount of deaths goes down. Okay? All right. This picture that we have here is called a scatter plot. And each little point represents one particular nation's percent of adult females who are literate and the mortality rate for that particular country. Okay? And you can see it's called a scatter plot because we have all these little points all over the place. Okay? And each one of those points represents a data point for a particular nation. But then we have this line drawn through kind of the middle saying, well, it kind of looks like a line if you compare if you put all the little data points together, and we say it's linear. And that line then represents a model of the relationship, okay? And that line is called a regression line, okay? So it's not perfect, not all the data points. In fact, most of the data points aren't actually on the line, but the line represents the model, okay? Represents the model of what's going on, or the relationship. Okay. The scatter plot are individual data points. Individual data points. Okay, if you go on and take more statistics, you'll get more information about scatter plots and regression lines. But a line has a slope. A line could go like this, having a positive slope. Or a line could go like this, having a negative slope. The slope is how steep it is. So if I have a really steep line like this, I'm expecting a high value for the slope. How steep? So maybe the slope is like, they usually use m for slope. Maybe the slope is like 4. If it's flatter, then we're expecting the slope to be closer to 0. Now this would be a negative slope. So maybe the slope is something like negative 1/3, something like that. How steep it is. Slope is used like on roofs. Around here you'll see all kinds of different roof lines. Some roofs are really steep, some are very flat. It's called the pitch of the roof, but that's another example of slope. Okay, so we have a way to calculate slope. There's what's called a slope formula. And the slope formula goes like this. It says if you have let's see, I used up all my space in my writing. So the slope formula you have to have 2 points on the line. 2 points on a line. And those points are going to be x sub 1, comma y sub 1, and x sub 2, comma y sub 2. Okay, so let me talk a little bit about that. 2 points make a line. Okay, so if you have any 2 points on a graph, you can draw a line between them. And we're labeling the points. This is like point 1, and this is like point 2. Each point has an x and y value, an ordered pair. These little numbers down here are called subscripts. They're not exponents. They're just saying, hey, this is the x value in the first point and the y value in the first point. And then over here is the x value of the second point and the y value of the second point. It's like a last name. Okay, so that's how we distinguish things. So the slope formula says the slope, m, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or sometimes we say the change in y over the change in x. You'll also hear people refer to it as the rise over the run. But we'll talk more about that when we go to the graphing. Okay, so right now we're going to concentrate on this formula here, the slope formula, which we're now going to know and love, and how to use it. So in example 1, it says find the slope of the line passing through each pair of points. Okay, so for this first point, one of the points is -3, -1, so like right there. And the other point is -2, 4. And so there's the 2 points, and then we're making a line between them. And what we're trying to do is find the slope of that line. So here's our slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so I usually tell students, go ahead and label your points. Make this the first one, and this the second one. And it doesn't really matter if you're like, oh, I want to make the other one the second one. That's fine. But you just have to be consistent. You can't like mix them up. Okay, now we're going to just put in the values. So y sub 2 is 4 minus y sub 1, which is -1, over, and then y sub 2 is -2, minus y sub, or x, did I say y? X sub 2, or yeah, x sub 2 is -2 minus x sub 1, which is -3. So there's only 4 numbers, so you're putting them each where they go. The tricky thing, I think, there where students mess up is the subtraction sign. So the subtraction sign is part of the formula, and so we're taking 4 minus -1, and then -2 minus -3. There, I said it a little bit better, maybe that helps. So now you have to do the calculating. So the slope is equal to 5 over 1, right? Or you can just put 5. Okay, so when you subtract a negative, that's like adding. That's how we get the 5, and that's how we get the 1. All right, now we'll do part B. So the slope, again, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this, I'm going to make this my x1, my y1, and this my x2, my y2. And I just put everything where it goes. So -2 minus 4 over 2 minus -3. So you're saying -2 minus 4, 2 minus -3. Okay, and then we have to do the calculating. So I'm going to get -6 in the numerator, and then in the denominator I'm going to have 2 plus 3, which is 5. So my slope for the other line, oh, I didn't graph it, is -6, 5. Okay, so we graphed that first line for part A, and we figured out the slope. The slope was 5, so that seems reasonable, pretty steep slope there. But I forgot to graph B, so -3, 4 is like right there, and then 2, -2, 2, -2, which is over here. And so that's going like this. You can see the slope is negative, yeah, because it's going in the other direction. It's going like downhill. And it's close to 1, and that's pretty close to 1 in the picture there, so seems reasonable. All right, so there's the slope. You can use the formula to calculate the slopes.